So hello friend, this is Kaustup Pathare. Welcome to our channel Making Maths Easy. So in the last video we have solved some sums based on derivatives of some implicit function. So today we will solve the sums based on derivative of the some implicit function. Also we will prove some function that dy by dx is equal to so and so. So let's start the video. So we have the function as if y is equal to 1 plus x into e raised to y. Then we have to show that this dy by dx, or the derivative of x with respect to y, is equal to e raised to y divided by 2 minus y. Okay, so we will start solving the sum. So first of all we will write proof, and then we will write the question as it is, as we have the following things, or the following things are given in the question. So we will write it as it is, and now we will differentiate on both sides. As I told you in the previous video, always in this case of implicit function we have to differentiate on both the sides, because differentiating on both the sides gives you the answer, because x is an implicit function of y and y is an implicit function of x, and the function of xy is always equal to 0. So my dy by dx will be equal to dy upon d of x will be equal to, we are differentiating with respect to x on both the side, so it will be d upon d of x of this function. So put a bracket and write this particular function, as I will differentiate using the UV rule over here, and the derivative of 1 is constant, so it will be 0, so which will be equal to 0 plus use u into v rule in order to differentiate. So for differentiating this we use the UV rule, so x into e raised to y, so dy by d upon d of x into e raised to y, which will be ultimately equal to 0. No need to write the 0 because 0 has no value, so x multiply by derivative or differentiation of e raised to y plus e raised to y multiply by derivative of x. In this way we have to do the u into derivative of v plus v into derivative of u in this case. So in this case we have to put the u into derivative of v plus v into the derivative of u, which is ultimately equal to x e raised to y. As I told you, whenever there is a y function in the expression or in the equation, and we are taking the derivative with respect to x, as uh, x is the implicit function of y and y is the implicit function of x, we need to put dy by dx in such cases. So put x e raised to y, as the derivative of e raised to y is e raised to y only, and the derivative of y will be with respect to x will be dy by dx. So don't forget to put dy by dx in such cases, plus then e raised to y in this case, and the derivative of x will be equal to, derivative of x with respect to x will be equal to 1. So no need to write, or you can also write it as you wish. So my dy by dx will be equal to x e raised to y. So I will write over here, so the dy by dx, or the derivative of y with respect to x, will be equal to this entire function, this entire function, so x into this entire function. Now we have to do one thing, we have to take the dy by dx terms on one side and the remaining terms on the another side. So this dy by dx term will go on the left hand side in such cases. So write dy by dx as it is, and minus, because this is positive, if it will go in the negative, on the left hand side it will become negative. So I am shifting it towards the left hand side and it has become negative, which is equal to e raised to y, e raised to y in such cases, and then my dy by dx will be equal to, and I will take dy by dx as a common, and then will be equal to 1 minus x e raised to y, e raised to y, and close the bracket, which is equal to e raised to y. in such cases. So my dy by dx, we have to prove that dy by dx is equal to uh, e raised to y divided by 2 minus y in such cases. So first of all, what is the value of 2? So we will do one thing, we will do one expression, or we will do one thing in such cases. As we know that e raised to xy as e raised to x y e raised to y into x is equal to y minus 1. So we will write over here one answer or one comment. So if x into e raised to y, x into e raised to y equal to, if y is equal to 1 plus x into e raised to y, so x into e raised to y will be equal to y minus 1 in such cases, and instead of e raised to y we will put y minus 1. So replacing e raised to y by y minus 1, we will get as uh, instead of putting e raised to y, we will replace it by y minus 1. So we will get the answer as this, and then this is minus 1, and we will put a bracket over here because it is minus, it is a combined whole expression, so we need to put the bracket in order to solve it. So my dy by dx will be equal to dy upon d of x of 1 minus y plus 1, which will be equal to e raised to y, and then my dy by dx will be equal to, my dy by dx will be equal to 2 minus y equal to e raised to y. So after taking 2 minus y in the denominator, we will get dy by dx is equal to e raised to y, e raised to y 2 minus y in this case. So it will be e raised to y 2 minus y in this case. So in this way you have to solve it, and we have to prove the rest of the sums. So hence we have proved the equation that dy by dx is equal to e raised to y divided by 2 minus y in this case. So we have got the proof, or we have got the answer of this equation, that we have to show that dy by dx is equal to e raised to y divided by 2 minus y. So we have done with the proof. So let's move to the next proof. So this is our next sum. So in this sum we have the following things: if y into square root of 1 minus x square plus x into the square root of 1 minus y square is equal to 1, then we have to show that dy by dx is equal to negative square root of, or negative root of 1 minus y square divided by 1 plus x 1 minus x square. So we have to prove it. So first of all, take the given things. The given thing is y into the square root of 1 minus x square plus x into the square root of 1 minus y square is equal to 1. So the given thing is 1. Now the second step, I have told you in the previous video that to take the we have to take the derivative on both the sides. So take the derivative on both the sides. So derivatives on both sides with respect to x, with respect to x. So we have taken the derivative on both the sides, and we are differentiating it with respect to x. So for after differentiating it with respect to x, we will get the variable as, or we will get the equation as d upon d of x of y into square root of 1 minus x square plus x into the square root of 1 minus y square, which is equal to d upon d of x of 1. As we know that the derivative of constant number, let's say 1, is equal to 0, so this will become 0. So we will put the 0 in the next step. So now we will differentiate the individual term. We will differentiate this, and we will differentiate this, and then we will apply the UV rule of differentiation for this, as well as UV rule for differentiation for this. So let's start. Now we have the differentiation of d upon d of x of y into the square root of 1 minus y into the square root of 1 minus x square plus d upon d of x into the differentiation of square root of 1 minus y square in this case, and which is equal to 0 ultimately, because derivative of 1 or the derivative of constant number is always equal to 0. So now let's differentiate using the uv rule, u into the derivative of v plus v into the derivative of u. So let us consider y as a v and square root of 1 minus x square as the u. So u into the derivative of v plus v into the derivative of u in this case. So in this way we have to differentiate the things. So same property or the same formula we have to use for the next function, which is this. So x into the derivative of square root of 1 minus y square yeah, into the plus square root of 1 minus y square into the derivative of x in this case. So we have the function as follows, as derivative of x into the square root derivative of x into the square root of the particular function plus the derivative of x of the particular function into the square root of x in this case, which is always equal to 0. So now uh, we have to differentiate, we have to go into depth and find the answer. So for doing this, take the derivative of, first take the derivative of root function, then take the derivative of 1 minus x square function. So we have y into the derivative of root function. Let's say use the multiplication symbol. So it will be square. What is the derivative of root x? Root x is equal to 1 upon 2 root x. So 1 upon 2 square root of 1 upon 2 square root of 1 minus x square in this case, and then we have to take the derivative of 1 minus x square function. As we know that the derivative of 1 is always equal to 0, as it is a constant number, and derivative of x square is equal to 2x. So we will write it in the further step or next step, plus the square root of 1 minus x square plus the square root of 1 minus x square into the derivative of y. So derivative of y with respect to x, as I told you in the previous videos, that the derivative of y with respect to x is dy by dx. So put dy by dx in this case. So dy upon d of x, and then plus x into the derivative of this function. So same property we have to use over here, as 1 by 2 root x. So it will be 1 upon 2 square root of 1 minus y square into the derivative of square root of, sorry, into the derivative of 1 minus y square in this case. So remember one thing, when you are differentiating with respect to x, never use dy by dx in this case, but when you are differentiating with respect to y, always use dy by dx in the particular function. But when you are differentiating with respect to x, never use dy by dx. And then we have the last differentiation is this, the property of differentiation, as square root of 1 minus y square into the derivative of x with respect to x. So the derivative of x with respect to x is equal to 1. Okay, so no need to write 1. So you can write square root of 1 minus y square in this case, so which may be equal to 0. So we have the 4 terms. This first term derivative is this. This second term derivative is this, and this third term derivative is this, and last term derivative or the fourth term derivative is this. Now we will further differentiate in the loop or loop differentiation. So for loop differentiation, we have first write this as y into the derivative of, as we have here, first we will differentiate this also function, and we will write over here because it will be lengthy. So in order to consume the space, we have to write the derivative of this function. So differentiation of 1 minus x square will be equal to the derivative of 1 is 0, so no need to write 0, and derivative of x minus x square is equal to put a bracket and write minus 2x, because derivative of x square is equal to 2x, and another one we have to write the denominator part, 2 into the square root of 1 minus x square. So we have to write it here, the denominator, the part which left in the denominator, we have to write it. And this again we have to write this, that square root of 1 minus x square into the dy by dx. We have to write it as it is, because dy by dx remains as it is, as it is a implicit function of x, and y is the implicit function of x, and x is the implicit function of y, and function of x comma y is equal to 0 in such cases. So we have to keep it as it is. Now look at this next function, as this function. So this function also we have to write it as it is. Only this part, only this much part we have to write it as it is. The rest of the part we have to solve it. Then it will be 1 x into the, or we can also write in this as in this way. So eliminate this 1 and write x upon 2 into the square root of 1 minus y square, and put a bracket over here, and then put a, the derivative of 1 is 0, so no need to write 0. So you can also, you can put the bracket, or you cannot put the bracket, it's up to you. So you can put a multiplication symbol, and you can write minus, here it is a minus symbol, minus, and y variable. So y variable, so we have to put dy by dx in such cases. So it will be minus 2y into the dy by d of x, and dy by d of x we also have to write over here. So minus 2y dy by dx, because the derivative of 1 minus y square is equal to, or the derivative of 1 is 0, whereas derivative of minus y square is equal to minus 2y dy by dx in this case, because we are differentiating with respect to x. So the y will be as it is, as as I told you in the previous video, that whenever we are differentiating with respect to x, we have to put, or we have to take into the picture as dy by dx in such cases, and plus the last variable, or the last function, or the last term in this case. So the last term we have to put it as it is, which is equal to, ultimately equal to 0. Now we have to do one thing. Now we have to take the dy by dx terms on one side, and the which are, and another other terms on the another side. So we will do it. So these are my dy by dx terms, these two are my dy by dx terms, and the basically the rest of the terms are my terms without dy by dx, or which will be equal to minus of this term, and which is also equal to minus of this term, because these terms are on the another side, because I am taking it, these terms are basically on the left hand side right now. So I am moving it towards, or shifting it towards the right hand side. So after shifting it towards the right hand side, it has become negative. These two terms have become negative, and the rest of the terms remain as it is. Okay, so I have shifted them on the right hand side, and I have to take the dy by dx in this case. So for taking dy by dx in this case, I have to take dy by dx as a common. So take dy by dx as a common in this case, and then we will get as dy upon d of x, and take it as a common, put a bracket, and you will get as square root of square root of 1 minus x square into the this function, plus this function, and put a bracket over here, which is ultimately equal to, take the minus symbol as a common, and put a bracket, and write over here this. So you will get as this symbol, and this minus symbol will go, because it is minus minus become plus, so we have taken minus symbol as a common, so it will become plus in such cases. So now we have to now we have to simplify the function, and we have to prove that this function, or the derivative of this function, is equal to square root of 1 minus y square divided by 1 minus x square, minus into the square root of 1 minus y square divided by 1 minus x square. So for doing this, we have to write, generally we have to write dy by dx as it is. The dy by dx will be equal to this function divided by this function. So my dy by dx, I am writing it directly. So my dy by dx will be equal to this function divided by the corresponding function. So this function divided by this particular function in such cases. So my dy by dx will look like this in this case. So now I will simplify the function. For simplifying the function, I want to take the LCM of the function in the denominator as well as in the numerator. This I have to multiply with this, and this corresponding function I have to multiply with this corresponding function in order to get the LCM or least common factor. So which will be equal to negative, write a negative symbol over here, and then take the divide operator and then multiply this particular function with the function and also divide it. So you will get the function as first of all use a divide operator over here, also another divide operator over here. So you will get the function as uh, y minus 2x, or we can say y into the minus negative 2x, y into the negative 2x plus square root of 1 minus y square, square root of 1 minus y square into the 2 square root of 1 minus x square in these cases. So it will be 2 into the square root of 1 minus x square, and this 2 square root of 1 minus x square we have to write in the denominator in such cases. So now another method you have to do, either the part which is left in the denominator, so the same thing we have to do in this case. So x into the first take a divide operator over here and then put this x into the you can also put y multiply by minus 2x, so which is same as x into x into minus 2y, which is same as x into the minus 2y, and then we have to use an add operator or addition operator, and then this you have to multiply with this, and which will become in the numerator in such cases. So multiply this with this particular function and you will get as square root of 1 minus x square multiply by 2 into the square root of 1 minus y square in this case, and then the part in the denominator which will left as it is, as my denominator part is 2 into the square root of 1 minus y square. So now we have to differentiate, or now we have to solve it. So in this case my this and this whole part, and this part in the numerator and this part in the another in the denominator numerator will get cancelled because I am dividing this with this. So the whole part will look like this. So minus or negative symbol of multiply by uh, this part, this corresponding part, divided by this corresponding part in such cases. So whenever you do such kinds of sums, you have to be careful while multiplying it. So even a single mistake or even a minute mistake can cause your sum wrong. So in order to solve this sum, you have to take the steps very careful. So which will be equal to this particular, so this this numerator and this the thing in the denominator will get cancelled in these cases. So this and this will be cancelled. So after cancelling this 2, this and this, we get the, and this 2 will also get cancelled in this case, because 2 divided by 2 gives me 1, and this function divided by the corresponding same function we are having over here gives me equal to 1. So in this case this function are cancelled in this case. So my final answer will be look like this, will be equal to square root of, we can put 2 square roots or we can take a single square root, and never forgot to put the minus symbol which is over here, the minus symbol over here. So always put the minus symbol whenever you are solving the sum. So which will be equal to this function multiply by, or this square root of 1 minus y square divided by square root of 1 minus x square and negative minus. So we can also write it as in a single root as under root of 1 minus y square over 1 minus x square in this case, under root of 1 minus y square over 1 minus x square in this case. So in this way we have to solve the difficult and complicated sums. So, and be careful while solving the sum, and always remember to put the symbols while solving. So if you forget to put the one symbol, if you forgot to put it, so you will get the wrong answer. So no need to do the lengthy procedure. Try to do the procedure as quick as possible, and try to solve the part individually, each and every term individually, so it will be easy for you. And use brackets while solving the sum. So we have proved the following expression as my dy by dx will be equal to square root of 1 minus y square divided minus into square root of 1 minus y square divided by 1 minus x square. So that we have proved in this case, which is ultimately equal to minus square root of 1 minus y square divided by 1 minus x square. So this corresponding function we have proved. So today this video was little bit bigger or little bit lengthier. So if you understand the video, please share, subscribe and comment on my YouTube channel. Please like my video and please subscribe my YouTube channel for more mathematics tricks and videos. So thank you for watching.